A few months ago, I made a tutorial video making the game of life in C# using WPF to do all the UI and graphics, and then using ILGPU to do the game of life stuff on the GPU and do it super fast. And that was a pretty good tutorial. Like, I'm happy with that, but I wanted something that would be easier to kind of do kind of turnaround tutorials and do more graphic stuff and less worrying about memory management and the like. And so I built a framework. I'm calling it ILGPU View 2 because I already made an ILGPU View 1, and that was like a shader toy clone. And this is pretty similar and can do the shader toy kind of clone stuff, but it also does some more fun stuff. And I think my TV's going off. Oh, and I crashed it. Well, the framework I built is really easy to start out with because all you have to do is fork this repo that I have here in my GitHub. Open the solution in Visual Studio. You have to have a kind of modern version installed and the .NET desktop development workload, which is super easy. I'm sure you can find a tutorial on YouTube somewhere to do it. And then you just open up the solution and look at the example project. So let's pull it up in Visual Studio, and boom, I'm there. So in the example project, there is a main window. It's a WPF project. There's a main window, and then there are these modes. The modes are the different render modes that you can select from in the dropdown. So if I run the project, you can see how I'm in the particle sim mode, but you can pick other ones. So I can switch to the debug mode, which is the file we're currently looking at. So let's walk through what's going on here. This onRender function is getting called once per frame, and it allows you an opportunity to execute things on the GPU. And this is when you would, let's say, write to the frame buffer. So this debug filter gets applied to the frame buffer. Now, what does that mean? Let's look at the debug filter. So the debug filter is applied to the frame buffer. So this function is called once for every pixel, and the output of this function is written into the frame buffer at that pixel. So whatever color you output of this function, that's what color that pixel is going to be. So if you look at this, you can see there's two regions. There's the region that's going from black to white, and there's the region that is a gradient from red to blue. That corresponds to these two return statements here. This bottom return statement outputs the gray color. Let's add it as a comment. Don't make fun of my spelling. I don't know if I spelled corresponding right. Okay, so this is the gray color that we're seeing in the grids, and this is the gradient. Blue to red gradient, I think. This is being picked based on this if statement, and this just multiplies x by 10 and y by 10. So there's a 10 by 10 grid, 10 by 10 grid, and every other every odd or even, depending on the x or the y, it will pick which color the gradient. It just gives you a checkerboard. So we can change this if we wanted to just return a color. So let's stop this. We'll comment all this out, and we'll just return 255, 0. So we'll return magenta, and we'll see here, it just outputs magenta and nothing else. We can do this tick trick here to make it change the color. Why not? See, it fades to white. You can even do like plus 127. Did that make it go gray to gray? No, it doesn't. I don't know how to do that. Anyway, Doesn't matter. Infinite possibilities. And we're going to get to some of those possibilities. But we'll get back to where we were. We've looked at how this filter is made, and we've looked at how the debug render mode is made. Let's make a render mode. Let's go over here, add new item, make it a class. What do we want to call it? Let's call it, I don't know. Let's draw spheres to the screen. So we'll call it, I don't know. Doesn't matter. Doesn't matter at all. We'll go to debug and just copy it just to cheat a little bit because we're going to need all these things. Okay, that's there. Let's add, let's do some fun stuff here. Make an unsafe struct. We'll make it fixed and we'll give it a, I'm not ashamed. I had to look up how to do that. Okay. I forgot how to do fixed arrays. I always forget how to do fixed arrays. Anyway, we have to do fixed arrays for some weird GPU memory related reasonings. Basically, this struct has to have a fixed size in memory. And if you do arrays normally, they're pointers and you just can't pass that to the GPU. So one of the options to get around that, and don't worry, if you keep watching this tutorial series, I will show you ways to get around that. But one of the options to get around it is to just use fixed arrays and to have a set amount. This looks dumb because I could just have one of these here, but I'm going to make this bigger once we're not, once we're rendering a sphere. Let's get that done first. Or not spheres. I should call them circles. Duh. Let's not do spheres. Spheres are not that much more complicated. I'm technically doing spheres for the particles, but we'll do circles. Thank you. Okay. Circle renderer. And it's going to do the draw circles filter. And then for this, we're going to say x equals 0.5, y equals 0.5, or y to the okay, we'll do that. We'll also add a radius. Okay, and we want to draw the spheres based on these x, y, and radius values. And this function is running once for every frame, or for every pixel in every frame. And so that means the output needs to be the color of all of the circles that are on top of this current pixel. And so how do we do that? Well, first thing we need is a vec3 for the color. And we'll set that to black, which is, our background color. We can actually set this to whatever. Let's make it 0.1, 0.6. Oh, that's a period. I was drinking a soda, but I need to get out of my way now. So we've got this color, and for every sphere, we'll just copy this. For all of these, if nope, what happened there? Why is this mad? X pose. Fine. I didn't want to call it that, but fine. Okay. This is not a good way to render circles. I just want to admit that. So we get the X and Y positions, radius pose. Radiuses. I hate myself, but I'm leaving it. So you've got all of those, the things that define a circle. And then if the current pixel X is less than X pose. Okay, I'm back and I'm pretty sure it works now. Oh. I forgot to change something. So in here, we want to set the mode here. So call this draw circles, make a new one of those, pass it in, set the default mode to 1 so it starts. Then, interesting. Doesn't like that. 0.1, real small. I don't think it's ever hitting anything. Whatever, good enough for now. Is that why? It's gotta be why. Yep, totally why. Okay. Oh, wow. Oh, it's a new one every frame. Okay. Okay, so let's talk about what was happening there. That is an interesting bug. So what's going on here is this constructor only gets called when you actually call when you call new. The default constructor is just whatever's up here. So if I had equals 0.5, can I do that with a fixed thing? I don't think I can. New float array. I don't know. You can't do that. But if these were predefined values, if these were all like integers or whatever, you wouldn't need to actually call new here if they were defined up in this section. But if they're defined in the constructor like this stuff, this only gets called when you actually call new. And so you can get rid of this thing. And we should probably store this in the class. Draw circle filter. I can just do that. Filter. Okay. So now this new function is going to get called. And I guess I could have just put a breakpoint there to demonstrate that, but oh well. So let's give them colors. We'll literally just copy this. Color R. There's a better way to do this. G. But I don't feel like doing it. B. Okay. Let's see. Oh, they're all really big. Make them tiny. Make there be 100 of them. Ah, they're all stuck up in the corner. Oh, because we don't want to do that. No. He does get an alt. Yeah. I can never remember how to do the multi-line select thing in C# or in Visual Studio. There we go. Let's make them bigger. And we'll add more of them. You can do a lot actually with these, just these fixed buffers. Oh, okay. Not that many. I think it has to be passed over as a parameter, and so I think that's why it has to be small. Gotta go smaller. Doesn't like that. There we go. Okay, I can do 100. But 100 times what? 4, 12, or no, 4, 8, 12, 16, 20, 24. 24 bytes times 100. That's not a lot. But yeah, there you go. That's a circle renderer. It's very easy to add more. I can show you off some different kind of things. I should actually, let's rename really quick. Actually, I'll show you through the main window. So the main window is down here. It's still in the example project. It's what has the kind of like base UI stuff. So there's the title and the FPS counter, and then there's the mode combo box and the render mode UI. When, for example, if I run this, the render mode UI is how you get all this slider stuff. The render mode the main window owns an instance of Render Manager. Render Manager is what lets you swap in and out the iRender callback, the kind of render mode things. So you can see in the main window constructor, I save back an instance. This is just for the UI builder. I create the render manager and then I set some callbacks. I could honestly probably get rid of this static instance if I wanted to. What uses it? Let's see. Sorry, I haven't looked through this code. Oh, I don't think it's necessary. Oh, okay, cool. Well, get rid of that. Boom, singleton gone. Good job, me. So I set some callbacks for the UI builder to do the FPS and to set what UI object gets kind of built in. And then I set up the render modes. So you can see here, this is where I added draw circles and where I set it to the default mode. And actually you can see here how the UI, this is actually similar to how the UI builder works. Let's make this prettier. So I have all the modes that I'm adding, and then these are the items that go into the drop-down box thing. And so this should be draw circles. Now you can see in the Dropbox, it'll say the right thing. Draw circles. I should honestly set the render window title to that. Anyway, so this adds the render callbacks, and then when the set render mode is called, we'll go into that. This is the render manager that again is owned by the main window. So it owns this dictionary of the render modes that you're building when you add render callbacks. And then when you set the render mode, it creates a new window, which is the second window that you see that actually is rendered into. So that's this render window here. So that is created right here when you set the render mode, and it is kind of like started up, and the render window owns all of the rendering and does all of that. So if I go into the render window, it has the callback that is currently running and the GPU. The GPU gets built and does all of the heavy lifting. So we'll go into that. The GPU is or the device. I actually in my development branch, this is renamed to renderer because it's the renderer. this kind of owns the render thread and manages all of the rendering and all the GPU stuff. So it builds all the IL GPU stuff. It builds a thing to hold the kernels. There's a weird trick that maybe I'll do a tutorial about if people are interested in, that allows this kind of function passing into kernels stuff that I use to emulate the shaders. That's all done in the device with all of these crazy functions down here that like cast object type array things. It's simple once you understand how it works, but it's kind of a pain in the ass. And I'm actually working to simplify it all. But that'll be done in the future. But I don't know, let's play around with it. Let's do something weird. Let's go to the particle simulator, or should I go to the ray tracer? Let's play with the ray tracer. I haven't played with that in a long time. So here's how I build the spheres. Where is it? Oh, it's an on start. This one is one of the early ones I built, so it's in a weird order. Here it is. Let's add 10. Start it. Oh, I should have set the default. See, now I've got these 10 extra spheres. I'm rendering. It's rendering very fast. I have screen scaling turned on, so right now this is rendering at 1080p. And it's 60 FPS. It's very quick. This is without any fancy data structures. This is just kind of like basic ray tracing, just done on the GPU. But yeah, there's other fun ones. Let's see, switching between the heavier ones it doesn't like sometimes. The particle simulator is a good one. Bit of Z fighting in the rendering that I've been trying to fight, but yeah, I'm rendering in a weird way. It's not. See how fast it goes when the particles are tiny. Let's add a bunch more particles. Say 100 million particles. How does that sound? Oh, well, that's not the particles. Ooh. I haven't tried the new particle renderer with this many particles. It might not like it. Oh, it might just be, oh, it's just building the particles. Building the particles and recording, building 100 million particles is kind of slow, you guys. It takes a lot of memory. Turn this way down so it can render fast. There we go. Look at that. Turn the color factor up. That's so fun. They're bouncing real high. Random factor up real high too. I think that's about it for today. This one's short and to the point, mostly because I tried to abstract away all of the hard work. Next time, next tutorial, it will be on render masks, which allow you to apply an image to another image. And so you can do things like the image filters, where I implemented, I didn't. ChatGPT implemented a bunch of different blur kind of filtery things. But you can have an input image, which is very cool. You can do textures. Maybe we'll add textures to the particle renderer. Maybe that'll be the thing that we do next. If you have any ideas or want to build something of your own, check out the GitHub, fork it, make some cool stuff, show it to me somehow. I don't know, make a pull request. If you make a really cool mode and you want to add it to the repo, I would love that. Anyway, I'll catch you next time.